Welcome back to CCCS214 Object-Oriented Programming 2 Binary I/O. Today we continue looking at some of the input stream and output stream subclasses. Specifically, we begin today with the object input stream and object output stream classes. Now, in previous weeks, we have used the file input stream, the file output stream classes to read and write bytes from and to files. That was followed by classes of the subclasses of the filter input stream class, data input stream, which allowed us to write something other than bytes, primitive data types, such as integers, strings, characters, floating point numbers, double precision floating point numbers, etc. And we also looked at the buffered input stream class, which first creates a buffer before opening the file and allows for faster I/O. Now, if you want to go up one further level of complexity, you might want to write entire objects to a file. And as you know, objects may contain multiple primitive data types inside of them. So what we'll see today in the object input stream and object output stream classes is that it's a way for us to write basically multiple variable fields, multiple variables contained inside an object with a single method call. So this is a little bit about the object input stream class. It derives, as we see, of course, from the input stream class, and it also implements two interfaces: the object stream constants interface and the object input interface. The object output stream class is similar. It is a subclass of the output stream class and also implements two corresponding interfaces: the object stream constants interface and the object output interface. So let me show you a small example that demonstrates these two classes. So the first example, actually they work together. In the first example, we'll write to a file and then another piece of code, another project, is going to basically read from that same file. And this is basically the code that we're going to run. The first one is called test object output stream, and as you can see, in this one, this contains only a main method, and it creates an object output stream object, very similar to the buffered output stream class that we used last week, and create an object called output. And we first call the writeUTF method on that, which works exactly the same way as the writeUTF method of other classes of the data output stream class. We then demonstrate the writeDouble method, which again works the same way as for the data output stream class. And then we see something new over here. We call a method called writeObject, and we have to provide, of course, an object in the argument. And we already know that we can simply use the date class provides us a ready object that we can use pretty much anytime, anywhere. So we're just going to write the date and time right now, going to create an object of that and going to write that object to file. And as you know, the date class has many different member variables inside it, so that'll adequately demonstrate the writeObject method. And then we close the file, and that's that. And then for the read demo, we're going to create another project called test object input stream, and this does kind of the same thing, but just in reverse. We create an object input stream object called input, pretty much the same way, and then we read first a UTF string, that would be the name. Then we read a double with a readDouble method, works the same way. We store these in local variables over here, and then we read the object, of course. And for that we use the read object method. You can see over here. Now, when you read the object, you also have to specify what class that object is of. And so we provide over here, basically we're casting the object to the date class over here, because you have to specify what class, how many, the Java needs to know how many bytes to read from the file, and it knows that once you specify which class this object is an instance of. And we store that in a new object that we create over here, date with a small d. And so now we have the read in values from the file in these three variables: name, score, and date, and we print them out to screen to demonstrate that we actually read this information from the file. So let me switch over here to test, first of all, to test ObjectOutputStream. So this is the same code that you just saw on the slide, and I'm going to run that. And there you go. So that should have created a file by the name object.dat. You go over here. So this is my folder for this project. That's the file object.dat. I'm going to copy that and I'm going to paste that into the working directory of the test ObjectInputStream project. Okay, now let me switch projects to test ObjectInputStream. This is the second code that we just saw. It's going to read this file object.dat, read the UTF string, read the score, which is in double format, and then read the date object. Let me run this, and it'll print it to screen, of course. And there you go. John 85.5, and the date right now is Saturday, October 26th, 9 o'clock 7 minutes. And that's that. Now, one related concept. Sometimes you have some member variables in an object that if you're going to, basically writing an object to file is kind of like backing it up. Sometimes you may have some fields, some member variables that are serve as that you do not want to back up when you back up an object, kind of like temporary variables that you simply don't want to include in that. Now, may also be maybe some other reasons that we won't go into, that stuff that we haven't covered in this course. But the point is that some objects can be written out, backed up into, converted into this serial bit stream, and some cannot. The ones that can be have to implement this interface called serializable. And I'll show you a demo for that as well. Sometimes you want to exclude some member variables from being written when an object is being written to a file. You can control that by adding a new kind of this transient keyword in front of those member variables, and those member variables will then be excluded from this kind of backup. So let me show you a simple example over here. So we have a class, let's call it foo, implements the serializable interface, and it contains, first of all, member variable integer v1. So v1, if you call write object on an object of class foo, v1 will be backed up. Then we have another second variable called v2, which is a double. This is a static variable, and because it is static, this will not be backed up. The third one is an object v3 of another class A, and for whatever reason, class A is not cannot be serialized, and to pass that information on, over here we add the keyword transient in front of it, which means that if you call the write object class on an object of class foo, in effect only this integer v1 will be serialized, will be backed up, will be written to that file. v2 will be excluded because it is static. v3 will be excluded because we specified it to its exclusion using this transient keyword. Now, another useful function of the write object and read object methods is that it can also be used to write entire arrays and read entire arrays to and from files. So another demo code for that over here, fairly straightforward. So over here, let's say we have a main method, and we create an integer array called numbers, and we have another array of strings called strings with small s, containing 3 strings: John, Jim, and Jake. So I want to write these 2 arrays to a file. So I open up an ObjectOutputStream. I create an ObjectOutputStream object, call it output with small o, and I use the write object method to write the numbers array and the strings array to file. Now you'll notice a single method call is going to write these 5 element long array to file, and for the second write object method call, this will end up writing 3 strings all at once in just one method call to file. We close the file and we reopen the file. We open the file as an ObjectInputStream and call the object input with a small I. I create over here an integer array called new numbers, and in it we write, or we initialize it with whatever read object is returning. So read object is the corresponding function to write object. And again, we have to do some casting. We have to specify what that whole bunch of bytes means. So we cast this entire object as an integer array. The same thing for the string array in the next line. Create a string array called new strings, cast the return value from the read object method as a string array. And just to make sure that we actually read back what we have written to file, we have a for loop over here which runs for the length of the new numbers array and prints out each element separated by a space. And the same thing on the next line, done for the new strings array. So let me switch over again. Let's test. Test object stream for arrays. It's the same code again that we just saw. Exact same code. Just going to run this now. And there you go. We wrote to file and read back the numbers 1, 2, 3, 4, 5 and the 3 strings John, Jim, and Jake. And if you want to verify if here's the file array.dat that we wrote in the beginning, array.dat. So that verify that file was actually created just now. Now, another very useful thing is, and this is not part of the class hierarchy that we've been looking at so far, is the RandomAccessFile class. Now, so far, all the streams that we've been working with allow us to open a file either for reading or for writing, but not both. The RandomAccessFile class changes that. So we can open a file for only reading or only writing or both. So this is the UML class diagram. So it has a constructor, close method, and some interesting new methods that we'll take a look at right now. So you already know that the basic idea of how to think about files or how to think about working with files is to remember there's always something like a bookmark in a book. There's a file pointer that points to a certain location inside the file, to a byte inside a file. Whatever operation you perform, whether it is a read operation or a write operation, happens at that location in the file. So here, for example, we have a file pointer at some location in the file, pointing to some byte, and we call the readInt method. Now, an integer in Java is stored as a 4-byte long number. So if you call readInt, that will cause reading the next 1, 2, 3, 4 bytes, returning those 4 bytes in the form of an integer, and it'll move the file pointer ahead by those 4 bytes. Now, there are many methods that come with the RandomAccessFile class. Many of them we are already familiar with, such as readInt that we just saw, readLong, writeDouble, readLine, writeInt, writeLong. So all of those are also available in the RandomAccessFile class. But besides those, we have a very important seek method, which can be used to reposition the file pointer to any location specified in the argument. And in the argument, it'll take a long number, and it will move the file pointer that many bytes from the beginning of the file into the file. If you want to know where the file pointer is currently located, you can simply call the getFilePointer method, and that will tell you the location of the file pointer in bytes from the beginning of the file again. Then we have the length method, which tells you the length, the total size of the file, again in bytes. The write character method over here will write, if you pass it an integer, it'll write a 2-byte or a Unicode character to the file. If you call the write chars, write character string method, you can write an entire string to the file. Let's see what else. So yes, so like I mentioned, you can open the file for reading or writing, or reading and writing. You can control that by the second argument that you provide in the constructor. Second argument is taken as a string. If you provide an R means read only. If you pass RW, it means reading and writing, read and write access. So let's look at an example. So this is the code that we're going to look at. So it's again, the entire code is one main method, and what we're going to do is we're going to open a file called inout.dat. We're going to open it for reading and writing, because the second argument to the constructor of the RandomAccessFile class is RW, this RW string. And after that, we're going to write some stuff to the file. We're going to go back and forth. We're going to move the file pointer from the end back to the beginning, somewhere in between, overwrite some of the contents. So we're going to be reading and writing from the file at different times. So let me switch over. So this is the same code in NetBeans, and here we have the main method again. So let me walk you through that line by line. So first off, we open this file inout.dat for reading and writing on this line by creating a RandomAccessFile object called inout. And just to make sure, if the file already exists, just to make sure that all pre-existing contents are deleted from the file, we use the setLength method, and we set the length of the file to 0, which means we've deleted all contents that were maybe already previously in the file, if the file already existed. So that's to make sure we start with nothing in the file. And then we have a for loop, and in that for loop we go from 0 to 199. So we run 200 iterations of this for loop, and in each iteration we write an integer, basically the counter variable I. We write those counter variables to the file. So we end up writing 200 integers, the numbers 0, 1, 2, 3, all the way up to 199. We write all of those to this file. And we know that each integer is 4 bytes long. So right away, as we're reading this, we know that at this point we will have a file that is 200 times 4 bytes long. So 800, we'll have an 800 byte file at this point. And next we demonstrate the use of the length method. So this should give us back the number 800. Next, we call the seek method and pass it an argument 0, which means we move the file pointer to the start of the file, to the beginning of the file. We do that, and then we call the readInt method, and whatever that readInt method returns is printed out to the screen, and with the text in front of it. The first number is, because we're reading the first number this way, the first number is blah, and the first number of course will be 0. That's expected. Then we're going to read the second number. Now the file pointer, after reading the first number, has moved ahead by the size of one integer, so 4 bytes. But we can also do that ourselves. We can use the seek method again. So there's no need to do this, but we want to use the seek method again. So we want to move it to 1 times 4. So we want to move it to the beginning of byte 4 in the file, which is the start of the second number. And the second number is 1. So we expect to see the string printed to screen. The second number is 1. Then we want to jump ahead to the 10th number, which means we jump ahead 9 integers, each integer being 4 bytes long. So 9 times 4, we jump ahead 36 bytes. And then we call readInt again, just like before, and print out whatever we get. The 10th number will be the number 9 in the file. Remember, because we started writing the numbers from 0. So the first number is 0, second number is 1. So just like that, the 10th number will end up being 9. So after we read the 10th number, we are at the beginning at the start. The file pointer is positioned at the start of the 11th number. And after doing a lot of reading, what we do now is we call writeInt, and we now overwrite that integer with that, which will be the number 10. We overwrite that with the number 555. Very out of place. And then we call seek again, and we go to inout.length, which is the length of the file, which means we're moving the file pointer to the end of the file. And at the end of the file, we then call writeInt, which is meaning we add another number at the end. So the last number written right now is 199. When we call writeInt, this is followed by the number 999. So we now have 201 integers written to this file. And just to make sure of that, we call the length method again, and this should return us the number. Well, how much? Well, we'll see. 804. Okay, retrieve the new 11th number. So what we do to do that is we call seek again. To read the 11th number, we move the file pointer to 10 times 4, byte number 40, and we call readInt, and we write out whatever we get to the screen, and then we close the file. So let me just run this code. There you go. Okay, so in case you've forgotten, so we wrote those 200 integers, and we call the length method. Size of the file is 800 bytes. The first number was 0, the second number is 1, then we jumped to the 10th number, the 10th number is 9, then we overwrote the 11th number with 555, then jumped to the end of the file and added another integer 999. And after that, we call the length method again. Call the length method again, and now the length of the file should have changed by the size of one integer. So it goes from 800 bytes to 804 bytes. And remember, in between we overwrote the 11th number. Just to verify that that actually happened, we jump to the start of the 11th number in the file, byte number 40, and we read the integer, and the integer should be 555, and the 11th number is 555. So a lot going on in this example, but it's kind of very interesting that you can read and write. We're reading and writing to the same file with the same object. Don't have two separate streams open for that. Okay. Just a few more comments. I'm not going to go into the code for this, but as long as you're dealing with primitive data types like characters and strings, characters and numbers, and not strings, the size of each field, each primitive data type that you write to file is always fixed. It's always known. Strings are the exception. Strings can really have any length. They can be very short, can be very long. So as you just saw with the RandomAccessFile example, if you know how many bytes each entry in your file is, you can jump to any record in the file. You just multiply the size of each record in bytes by and multiply it with the position number of the records before it, of the record that you want to jump to, and you minus one, and you jump directly to a record in the file. Now that is possible if the size of each record is fixed, if it's the same. If your records include strings, that is not necessarily the case. Now there's another example in the book called Address Book, which also uses a random access file, and this is a slightly more interesting example of a database than the one that you did as your programming task last week. And we can, now as you can see in this example, each field will be a string. We have a name, we have a street name, we have a city name, a state name, and a zip code. So these are all strings, and they can be of variable length. Now, in order to enable this kind of the use of this RandomAccessFile class, if we fix the size of each of these strings to a fixed number, then the size of each record becomes predictable and uniform. And that enables us to use a random access file. So in this example over here, so each record was these 5 string fields. If each string has a fixed size, then you know that how many bytes you have to jump forward to jump from record 1 to record number n, for example. And those records can really be anything, can be students, can be anything else. And the way to do that is to make sure each field inside a record, the name, the street name, the city name, the state name, they all have, across records, they all have the same length. Now, for that, you can add, you can use, for example, over here we have this sample code, which basically takes an input field and we can specify what the size of that data item should be, and it'll pad some blank characters to it at the end if the entry, if the data value is shorter than the available space, and it'll truncate it if it's too long. And the end result, and this class is then used in this example called address book, which is basically what you see over here. Now, I'm not going to show you the code for that because this example uses a graphical user interface, as you can see over here, and unfortunately the code that you have to write in Java to create a window, a GUI, these buttons that you see over here, these labels, it's quite tedious, and we might find it overwhelming at this stage because we haven't gone into graphical user interfaces, but I'm just going to show you what that looks like. So this is the address book example over here, which uses this fixed length string IO class that I just showed you. So and I'm just going to scroll through that just to give you an idea. So there's this JButton class, for example, for all those buttons: add, first, next, previous, last, etc. And see, it's not insignificant. So even to create something as simple as that, you have to write a lot of code in Java. Here it is. So if you want to use it, if you want the code, I can share that with you, but I don't expect you to know how to make this or necessarily understand the GUI part of this. Okay, and that is the end of the chapter on binary IO. And